Hello guys, so in this video I'm going to explain the working of insertion sort. So we can see a set of array here, so which is in random order, that is unsorted. So the way insertion sort works is that we are just taking the first element, that means this is zeroth element, that's why I said first. So this element we are just considering as key, and what we are going to do is that we are just comparing it with the previous elements. So I'm comparing 3 with the previous element, that is 4. I'm going to check if this key element is less than the previous element. In that case, I'm just swapping it. By this way insertion sort works. After this first iteration, it will be like 3, 4 and the rest as it is. Now on the next iteration, I will be considering 1 as the key, and I'm just comparing it with the previous elements. So at first 1 will be compared to this 4. As 1 is smaller, 1 and 4 will be swapped, and 1 is compared with that 3. As 1 is smaller, 1 and 3 will be swapped. So it will be like 1, 3, 4 and the rest as it is. By this way it will consider all the other elements and the key, and it is compared with the previous array, that is sorted array. So this is how insertion sort works. So I hope you understood the idea behind insertion sort. So let's see how we can implement it in Python. So consider this array that is in unsorted way 9, 8, 3, 5, 2, 1, 7. So as I told in insertion sort, we are starting from the first element. So I'm just doing the first iteration, that is length of array, and I have start from the first element, that is 1 comma length of array. So we are just checking it from here. Now what I'm going to do is I'm going to consider that I as key. I means as it is starting from 1, 8 will be the key at first. Now what I'm going to do is I have to compare it with the previous elements. So I'm going for a while loop, while key is less than array of I minus 1. So what this means, that if the key element is lesser than I minus 1, which means 9, so if in that case I'm going to swap both of them. So array of I minus 1 comma array of I is equal to array of I comma array of I minus 1. So now we swap, but there is one more condition that we have to give. So suppose we are comparing this with this, as it is smaller we are swapping it, and in the next iteration I will be minus 1. That means it will go here, so it will go in a cyclic order. So it should not happen. So in that case we are giving I greater than 0, so that condition should stop here. So that's why we have to give that condition. So after this I have to increment I. So in that next case I will be previous element. Suppose this is our key and we are comparing it with this element, as it is not smaller, we are just going for the next element. That's why we have to decrement it. So this is how insertion sort works. That's all. Let's see whether it works. Now we can see that our array is sorted. So this is all about insertion sort. So we can use this insertion sort when there is only some numbers that has to be sorted in a set of numbers, or we can do it like as it is having a worst time complexity of O of n square. Suppose whole is in descending order and we have to do that sorting, then it will take O of n square of time.